Hello everyone. In this video we're going to be discussing one of the minimum spanning tree algorithms. This is probably the one you might have come up with on your own if you stared at this problem for a really long time. So let's figure out how we're going to do it. First, we're going to choose some node to start creating the spanning tree at. So for this one, I'm going to choose this node over here, V1. And then what I'm going to do is I'm going to look near for an edge that is the least edge touching V1. If we look at this, maybe we go, well, the least edge touching V1 appears to be this one that has a weight of 7 going up to V2. So I connect V2 to the minimum spanning tree. So let's color V2 to say that it's in the minimum spanning tree. And now I'm going to look for the minimum edge that connects one of the orange nodes to one of the white nodes. I have a couple of options. I can check this node, this edge down here that has a weight 8. This one has a weight 2, 11, and 6. The best one of those options appears to be this one with a weight of 2. So then I'm going to color V6 to be orange because it is now included in my minimum spanning tree. Now I'm going to look for, again, the minimum weight edge that is connecting an orange node to a white node. I have a couple of options. I can go this node with 6, 11, 9, or 7. The minimum of those would be this this edge with weight 6. So I'm going to choose that edge, and therefore color V3 to be part of my minimum spanning tree. Now, let's see what the minimum edge is. I have 11, 9, and 7 still, but I've now this option taking this 5 up here. So let's take that option. It's better than the 11, 9, and the 7. And then color V4 to be orange. From there, we still have that 11, 9, and 7. We also need to consider this edge that has a weight of 3 and this edge that has a weight of 4. So let's take the edge that has a weight of 3. And now we have lots of edges to consider. We have an 11. Oh, sorry, let me color that. We have an 11, a 9, a 7, a 1, a 5, a 4. The best of those is definitely this edge with a weight of 1. So we're taking that edge and adding V7 to the spanning tree. Now, we only need to add V8, and we can choose the 4, the 5, or the 7. Might as well choose the 4, that's the smallest of them. Now, if we check, we have no more white nodes to add to the spanning tree, and we've built some sort of spanning tree. Notice we never considered edges connecting from orange to orange. Because this is a tree, we do not want to create cycles. And if we had ever chosen an edge connecting from orange to orange, we would have introduced a cycle into the tree, which therefore would have stopped it from being a tree. From our introduction video, you might notice this is the same tree that I came up with when we were computing the minimum spanning tree there. So this algorithm will keep track of some set of nodes in a tree. In this case, they were colored orange. And some set of nodes not in the tree, colored white. And we are connecting from the orange to the white. So we will see the actual code for this when we analyze it, but that is the idea of the algorithm. You separate the tree into the set you're currently considering and the set that you will consider in the future. This is called a greedy algorithm because anytime we had a choice to make, we always made the current best choice. We never considered the long run effects of what we were doing. When I added in the edge that was the minimum weight going from V2 to V3, when I added that edge in, I didn't think about the ramifications of, will this give me good choices in the future? So a greedy algorithm is typically one where your decisions are the locally best decisions in whatever sense locally makes sense. So we always are making, at the current moment, the best possible decision. That may sound like that's obviously going to work, but for several problems that we will see, that will fall apart. So whether or not this algorithm actually works is going to be the hard part. A bit of coding and analyzing the runtime will be a bit messy, but it's not going to be too bad. The real mess of this algorithm is going to be understanding how is it actually correct and why does it work, which is a useful skill we'll have to develop while analyzing this algorithm. It's sometimes called Prim's algorithm. That is the name of this algorithm. Prim, Prim's algorithm. And it is a very reasonable introduction to greedy algorithms. But for now, we are going to stop this video, and in another video we will write down some code and analyze that code. For now, we are going to simply rest with the idea before we get too deep into the details.